This video is going to show you how to assign oxidation numbers. So your notes had rules for assigning, and I've condensed those into this format. I want you to put this on a note card. 1. Rule 1. Oxidation number is 0 for elements. 2. It's equal to the charge for monatomic ions. That means one atom ions, such as iron 2 or iron 3. 3. It's equal to -1 for fluorine in compounds. So fluorine has to be in a compound. If it's by itself, it's the element and it gets a 0. Rule 4. Oxidation number is -2, usually for oxygen, but watch out. In peroxides, oxygen is -1. Also, oxygen can be other numbers, positive, negative, fractions. So usually -2. In all the polyatomics that aren't peroxides, it'll be -2. 5. Oxidation number is the positive one for hydrogen in covalent compounds. That means a nonmetal bonded to a nonmetal. But hydrogen will be a -1 for hydrogen in hydrides. That's when you have the metal bonded to a hydrogen. Metals always get the positive oxidation number, so they can't both have positive because the sum has to be 0 in a compound. So if the metal's taken a positive oxidation number, hydrogen is forced into a -1 state. So watch out for that. When hydrogen is with a metal, you're going to give it a -1. Every other time it's going to be +1, unless you're talking about the element hydrogen, H2, and then you would say it's 0 for elements. Last rule, the sum of the oxidation numbers in a compound must total 0 because compounds are neutral. There's no net charge. The sum of oxidation numbers in a polyatomic ion, however, has to equal the charge on that ion. So those are the rules condensed in an easy to work with format. Now let's do some examples for practice. You have to learn these rules. Example 1. CH4, methane. We all know this is methane. Hydrogen is bonded to a nonmetal. It's covalent, therefore you're going to give it a +1. Think of assigning oxidation numbers as a circle of work. So you're going to take the individual oxidation number times how many atoms there are of that type. So 1 times 4 is a +4 total. Carbon has to contribute to the +4 so that the sum, rule 6, is 0 because methane is a compound. There is no charge. So the sum of the oxidation numbers is 0 in a compound. So what do I add to 4 to get 0? -4. There is one of them, so -4 divided by 1 is just -4. And so there you have hydrogen is a +1, and you do have to indicate plus. It can't be understood. And carbon is a -4. And that is how you would assign oxidation numbers for methane. Example 2. This is a one atom ion, monatomic ion. So for monatomic ions, this is rule 2. The oxidation number of lead is simply the charge on the ion. It's a +2. You're done. Example 3. Oxidation number of neon, it's the element, 0. That's rule 1. Let's do, this is example 4. This is a little strange one. Oxygen difluoride. It's covalent because it's a nonmetal bonded to a nonmetal, so it's covalent. But we want to put a -2 on oxygen, but hold on a minute. I thought fluorine in a compound always was -1. Well, it is. So don't start assigning an oxidation number to oxygen. Always go to fluorine in a compound first because it's always -1. Do your circle. -1 times 2 fluorines makes a total of -2. It's a compound, so it's got a total to 0. That forces oxygen into a +2 state. 2 divided by 1, oxygen is +2. And so we have oxygen is actually a +2 in this example, and fluorine takes its usual in a compound, -1. So start with fluorine. Anytime you have a compound that has fluorine, go to fluorine first. Next example. Let's do iron 3 oxide. Okay, so oxygen, this is not fluorine, so I'm okay to put a -2. Times the 3 gives me a total of -6. It's a compound, it's got to sum up to 0. That means total for iron has to be a +6, but it's got to be divided equally between the number of iron you have. So 6 divided by 2 is a +3. So this is going to give us iron in the +3 state. This is going to give us oxygen in its usual -2 state. Now for those polyatomics. Example 6. Let's do the chromate. CrO4 2 negative. Okay. For a polyatomic, the total, the sum of the oxidation numbers must equal the charge. This -2 has nothing to do with oxygen's oxidation number. So think of it as separate from what you're doing over here. So oxygen, -2, times 4 is a -8. What do I add to -8 to get a -2? A +6 divided by 1 chromium means the chromium is in a +6 state. So you would say chromium is +6, oxygen -2. Now what happens when I get another polyatomic that contains chromium? So example 7, I'm going to leave this up here to show you that chromium is not the same oxidation number in all of its ions. But if you do dichromate, Cr2O7, 2 minus, again, the sum of the oxidation numbers has got to equal the charge on the ion. Oxygen again is a -2 times the 7, -14, plus what is -2? You would tell me 12. Divided by 2 chromium atoms. The total charge has to be split equally among however many atoms of that type you have. 12 divided by 2, 6. So this one gives me chromium is +6 and oxygen is -2. So it did come out to be the same, but doesn't have to be. All right. Now we're going to manganese. Okay, so you have example 8. We've got the permanganate ion, and then we have a compound, manganese dioxide. Okay, so here we go with the sum has to be the charge. Oxygen -2 times 4, -8, plus 7 is -1 divided by 1. So this gives me manganese in a +7 state, oxygen in a -2 state. In the compound, oxygen, -2 times 2, -4. This is a compound, it's going to be 0. That gives me a +4 for manganese, divided by 1. So the metal will not always carry the same oxidation number. You have to work it out to figure it out. And then there's even a monatomic ion for manganese. The manganese 2 Monatomic ions, oxidation number is the charge. So I have manganese in 3 different forms, but it's still manganese, it's still that atom. But it can have a +7, a +4, or a +2. And that's how to assign oxidation numbers.